Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, helping you learn wherever you go. I'm your host, Zach Memis, as we continue on with CompTIA Net Plus. This is IP address assignments this episode, and Wes Bryant is going to help us out because he's a great guy. Wes, nice to see you. Thank you.
Hey, Zach, thanks for having me back. That's right. We're going to be, we've been talking, depending on when and where you start your journey in Net Plus, it really depends on what show you're watching or episode you're watching, but we've really been kind of journeying through IP address structure. We've been talking about IPv4 addresses, things like classful addressing, classless addressing. In some episodes, we talk about things like IPv6, right? Internet Protocol version 6. Well, we're going to talk about how do we actually get these addresses. Now, I will tell you that in one of the episodes, Network Services, we discussed pretty much in depth DHCP, right? The Dynamic Host Configuration Protocol. But since that is part of how we get our IP addresses, we're going to go ahead and we're going to put that here as well. So keep in mind that if you want a more in-depth look at the DHCP service or the role, definitely check out our Network Services episode, and you can check that out. So I want you to understand that we're going to kind of brief over it in the context of address assignment here, but we go into things like options and the scopes, if you will, and a little bit more on that server role if you need to understand it. So let's go ahead and let's dive right in, all right? So I've kind of let the cat out of the bag before we even started, right? We're going to talk about how we get these IP addresses, and there's really two different ways. I'll say there's a third way, and I'll come back to that third way here in a second, but there's really two different ways, right? There is one way that is a very manual configuration process, all right? It has its place, but what it does is what it means is that if I say, Zach, you're the administrator, and here's the IP addresses that I need you to assign to these components, right? Well, that means that Zach is going to have to manually put in the information, all right? And in fact, let's show you. So I got a Windows 10 machine here, and we will look at the properties of the network adapter there, provided I can type my password right. We're going to see here in just a second. Now, once we get logged into the machine, all right, the next thing we'll do is we'll bring up the properties of the network interface. Now, my head's kind of covering this up, but there's a little monitor icon here, and if I right click on it, I can choose Open Network and Sharing Center, and we'll let Network and Sharing Center open up, and then what I want to do is I want to get into this Change Adapter Settings. All right, and these are our network, basically our network adapters, right? I got a Bluetooth one that I'm not worried about, and I got a virtualized loopback adapter that we've talked about in other episodes, but the one that I really want, right, is Ethernet 0. And if I right-click on that, I can choose Status, and I can get a really quick heads-up view on the properties of the network adapter by choosing Details. All right. Now, one of the things that I want you to keep in mind is that this is a statically assigned address, all right? We're going to come back to why that is here in a second. But when we talk about static addressing, if I close this down, right-click again, and choose Properties, all right, what I want is I want the TCP/IP v4 properties, right? So if I scroll down and look at the protocol bindings, remember when we talk about binding, when you bind a protocol to a network adapter, just think of it as you're teaching that network adapter how to use that protocol, right? You used to be able to install a bunch of different protocols here. I'm not sure if you can. Oh, well, see, you can do reliable multicast protocol, but used to be you could install things like IPX, SPX, and stuff. I think it was NetWare, if I remember right. But we're going to go ahead and we're going to look at the Internet Protocol version 4 here, and we're going to go ahead and choose Properties. Now, notice that it says use the following, all right? When we statically assign an IP address, it's a manual configuration, and what that means is that every one of these properties I'm going to have to manually enter. Like I said, if I gave Zach a task and said, hey, You're the network admin for this network here. Here's the IP addresses I need assigned to these machines. That means Zach would have to go here, and he would have to, let's say it's 10.network, 10.10.10, and I'm going to just make this easy for me, 10.10.10.10. All right, and I say, okay, well, it's going to be this subnet mask, 255.255.248. And then I need a default gateway of 10.10.10.1. All right, and then last but not least, I need you to give it, here's your DNS server, right? Maybe I say, okay, you're going to use 8.8.8.8, or you're going to use maybe maybe use the default gateway because it's handling just sending DNS requests for you, right? And I choose OK. Now, all right, now we choose close. All right, here's the thing. That was one network adapter that was configured. All right, just one. Imagine if we had not just one client in our network. All right, we had 1,000 computers.
It would take you quite some time.
That's right. Now,
One at a time.
if you're an hourly employee, you're like, bring it on,
Hey.
right? I'm going to start now, and it's kind of like mowing a 500-acre lot. By the time I'm done mowing it, I got to start over again, right? But that's not the only thing, all right? What is the possibility that if I got in here, and how many, and this is more rhetorical, but how many do you think I would get through in manual configuration before I would make a mistake? Maybe the subnet mask wasn't supposed to be 248, it was supposed to be just classful 255, right, .0. So static is not only a very manual process and could be a very time costly, if you will, approach, time consuming, thank you. But there's also problems with configuration errors too. All right, so the other way would be to dynamically obtain an IP address. And again, we could say obtain an IP address automatically. Now be very careful with that automatic. I'm going to come back because it's automatic to the client, but it doesn't just automatically happen, right? Nothing in computers or nothing in networking happens unless we configure it that way. But there's a third type that truly is automatic, and that's why I said just be careful with that. That's why I always say dynamic. And what this says is, you know what? We're going to go ahead, and what we're going to do is we'll close this, and we're going to call out to a DHCP server, right? Remember, we've talked about the DHCP servers, Dynamic Host Configuration Protocol, all right? And we're going to leave it at that. Now, do we have in our networks a use for dynamic and static addressing? All right, so one done through DHCP, one done through the manual process. All right, well, yes, we do. When I have things like laptops, right, let's talk about dynamic addressing. When I have things like laptops, workstations, or even bring your own device, BYOD, I'm probably going to want to use DHCP because that means the moment these computers turn on or they join to their networks, remember that 1,000 computers, they can call out to the network and I can have a DHCP server configured out there. That's why I said it's not automatic. Your administrators have to bring the DHCP server online and configure those DHCP options that we talk about in other episodes. That's right. So once these computers come on, they can call out to the network and they can say, hey, I need an IP address, all right? And they go through what's known as the DORA process, right? We've talked about this, but if you're not familiar with it, we'll talk about it again, right? So your clients can send out what's known as a discovery packet. All right, the discover packet, just understand, that's like saying, hey, anybody out there got an IP address? So it broadcasts this communication out to the local network and says, I need an IP address, all right? Well, the DHCP server, remember what servers do? They're listening for service requests. The DHCP server says, oh, yeah, I got that broadcast communication. I can hear that too. I'm a DHCP server. So here, I'll make you an offer, right? That's the next packet, right? I'll make you an offer, and here's this IP address and maybe even some additional configuration parameters. We talk about the server options in the other episodes as well, right? Then the last is a formal request, right? Because the discovery packet, you might say, well, wait a second. The request is my client telling the server, yeah, I'll take that IP address. Go ahead and just give me that IP address. Well, I've always, I remember when I was first studying this, Zach, I thought, well, why would I send a request to the server? Didn't I send a discovery packet that said, hey, I need an IP address? Why would I turn around and make a request? Well, that's because your discovery packet is a broadcast communication. all DHCP servers that are on that local subnet will hear it. And if you have more than one,
it goes to everybody.
That's right. So more than one DHCP server could be listening out, and more than one DHCP server could make you an offer. So which one do you take? You send a request to the very first DHCP server that responds.
That makes
right?
sense.
First one that responds, you're going to say, okay, you responded to me first. I'm going to make a formal request and send it back to you so you know I want your IP address. And that lets all the other DHCP servers know, oh, okay, he's going to take DHCP server 1. He's going to take that IP address and all those configurations. We'll go ahead and we'll put the IP addresses that we offered back in our pool addresses, and we can allocate those to other computers if they ask for them. Then last but not least is an acknowledgement of the DHCP server. And consider this the last process, kind of like when you go in and you get a rental car, right? You say, I set up, I need a rental car. Here's a rental car. Okay, I'll take that rental car. Now let's go ahead and sign the contract here so that we know here at the rental car company that you are the one that has that car for a week. Well, your DHCP server says, the acknowledgement comes back to the client saying, yeah, okay, you are going to take my IP address? Well, I got to kind of bookmark that in my little database here so that I don't give that IP address out to any other computer. So now I know that's going to be yours, and it's going to be yours for the duration of the lease period, typically 8 days. So that whole process is the dynamic addressing process, and it's what we do to things like clients, workstations, and laptops. So where does the manual configuration, the static addressing, does it have a place within our networks? And the answer is yes. It does have a place in our networks, right? Devices that we don't want to potentially change their IP addresses because we always want to find them, we want to use a static address. Why is that? Well, remember we said that DHCP is dynamic addressing. And what do I mean by that? You have that IP address for whatever the lease duration is set by the admin. And again, by default, it's typically 8 days. At the end of 8 days, if you can't communicate with that DHCP server or another DHCP server, your IP address is going to be let go by the network adapter. Just lets it go. And now you don't have any more IP address, right? Well, that might be okay for a workstation, and sometimes it's not. But we might be able to get by with that on a workstation. Our network devices that move our traffic across our network, our servers that are providing a resource, we don't want a potential for them to lose their IP addresses. We don't want a potential for their IP addresses to change, so what do? Well, I go into the server operating system, unlike the client operating system, and I tell it, I want you to use this IP address. Looks like my server shut down here on me. And if I do the same thing down there in the lower right-hand corner, if I right-click on the little network adapter icon there, and I choose Open Network and Sharing Center, we're doing the same thing that we were doing on the client. But the difference this time is that we want, in this case, this is a domain controller, right? Chances are I want my workstations, when people log on, to be able to find the domain controller so they can authenticate and they can actually log in and get some work done, right? Well, that's why things like your connectivity devices, your servers, even your printers, I don't want my network printers changing their IP addresses. I don't want my mail server to change its IP address because all my clients are pointed to this IP address, and a lot of times they're pointed by name, but I don't want the devices that are providing the resources to change their IP addresses. That would be like your mail carrier delivering mail to your mailbox. Once that's done, that day you grab your mail out of it and you rip the mailbox out of the ground and you throw it in the backyard in the pool. The next day the mail carrier comes by and says, well, there was a mailbox around here somewhere. I don't want IP addresses like on my mail server to change because then my software might not know where to find it. So we go in here to something like the server and we'll do exactly that. We'll do the same thing. We'll come into the TCP IP v4 properties and we will manually assign it an IP address, right? And this is where static assignments come in handy for us, right? When you have things like network devices, your servers, your printers, right? Devices that we don't want IP addresses to change. Now, there is another thing that we could do, right? And I got to give props to our chat room out there, right? Because they're a smart crowd, and we're getting to this, right?
Thank you, David.
There is another thing that you could do to things like network printers, right? And I could set what's known as an IP reservation, all right? Now, we've talked about reservations in the DHCP network services episode, but I just want you to remember if I was to set up an IP reservation, what that means is that based on the MAC address, when this computer calls out to the network and says, hey, I need an IP address, our DHCP server says, well, wait a second, I see that, yeah, okay, I see your MAC address there. Wait, I've got a reservation here for you. So here, let me give you this IP address, and you will have that IP address anytime you ask for one, right? So it's kind of interesting. Our chat room viewer out there says, hey, it's kind of like a static DHCP, and it's true that it is, right? That just means that you are going to manage that IP address through DHCP, but it's going to get the same IP address every time. So it's a great way that you can use the dynamic host configuration protocol to kind of do like a static mapping without even putting your hands on, right? So hands-free static DHCP, I guess you would say, right? So we do have...
No static cling.
That's right, no static cling. So those are some of the reasons we would use dynamic addressing. We would use static addressing, and then another one where we could actually set up an IP reservation that says anytime you go through the DORA process, you send that discovery packet to the broadcast communication address, and I hear it, well, I'm going to give you an IP address offer, and it's going to be this IP address every single time, right? Okay, so what happens if we call out to the network and we do our whole DORA process, right? And if we could, well, let's go back to our discover, offer, request, acknowledge. If you can remember these, you can remember how an IP address is
DORA the
achieved.
Explorer.
That's right. Well, what happens if the DHCP server is? I tell you what, we're gonna take everything out. Oops, maybe. All right, I'm going to take everything out, and we don't get to this process, all right? What happens if we get this far in the DORA process, and that's all? We don't get any farther.
Hello?
Hello? Anybody out there? Anybody got an IP address? Well, what happens if a DHCP server doesn't respond? And that's where an automatic addressing style comes in, and that's why I wanted to be careful. Even though we've seen within our network adapters that it said, looking at the properties of the network adapter, right? If we, again, kind of drill back in here and we look at IP properties, notice it says obtain an IP address automatically. Well, what happens if you, again, you've got DHCP set up and you call out for that DHCP server, and again, it's snoozing. Well, this is when you are going to rely on alternate configuration. Alternate configuration is something known as a PIPA, Automatic Private IP Address. This truly is automatic, right? Because this doesn't require me to configure it. Now, when I say it doesn't require me to configure it, this is the default. I could change this if I wanted to, but what that means is that if I hear crickets in the background when I send out that Discover packet, and by that I mean I don't get a response back from the DHCP server, it is going to fall back on what's known as a zero config technology, short for zero configuration. It's going to automatically assign an IP address to this computer. Let's see what that looks like, right? So I'm going to go ahead and I have set this computer up for DHCP. And we're going to choose close. It says unidentified network, and I don't have a DHCP server set up on this network. Or do I? Let's find out. Now, we've been dealing pretty much with the GUI within this episode. Let's drop down to our command prompt because I want you to remember the utility we use to look at the properties of our network adapter, right? It's the ipconfig utility, IP configuration, and if I run that, oh, it looks like I do have, looks like I have a static IP address. Let me see what's going on here real quick. Let me just check my network adapter here and see exactly what I did. Just want to make sure that I don't have remnants of, I do not. Oh, you know what it is? I bet it's that loopback adapter. That software adapter is getting in my way here real quick. Doing something kind of messed up there. We don't need that right now. I just need a single adapter. Let's see if I run ipconfig again. And you know, it's still doing that. All right, so it looks like it's cached the information, even though it doesn't seem to have an IP address. So let me go ahead and disable. I'm going to force the DORA process here because it seems like it's caching a little bit of information there. It's probably got a lease that it's already reached out and obtained an IP address. And it's probably saying, well, I already see that lease was valid before, and it might be caching that information. Okay, here's what I kind of want to see. Notice how it's kind of hanging unidentified?
Right.
It's just saying, all right, well, what's the address? Well, now let's drop back down to our command prompt, and let's see what we see now. All right, so let's go ahead and rerun our IP config. And yeah, it's still provided that. You know, I think I know what's going on here. So let me go ahead and check something on our virtual machine here, because even though I said we don't have DHCP running on this virtualized network, I have a feeling that in the hypervisor or the virtualization software might be actually providing DHCP. And it was, but it looks like it's disconnected now. I'll tell you what, so you can actually force the DORA process. You can either do in the GUI like I did, you can disable it and then re-enable the adapter, or you can actually run ipconfig /release, all right? And when you do that, you might get an error if you have these pseudo interfaces like a loopback adapter, because a loopback adapter is not calling out, it's not doing DHCP, it's a software-based adapter, so it might tell you that it can't perform that. And then on the Bluetooth adapter, it's not going to do DHCP. So that's why it says no operation can be performed on the Bluetooth network connection. That's okay. I'm not worried about Bluetooth. So let's go ahead and clear our screen. We've released the IP address. Now what we need to do is an ipconfig /renew. And that starts that DORA process over again, right? I did it a couple of different ways so you guys can see that. Just disable in the graphical user interface. Just right-click on the network adapter, disable it, re-enable it, and if it doesn't have an IP address, it'll call back out to the network, and it'll start that process over again, hopefully obtaining an IP address. Now, my purpose in doing this is to show you what happens when a DHCP server isn't on the network. In this case, it kept the IP address because the hypervisor, the virtualization software, was providing DHCP within the virtual network that I'm on. So we had to disable that, turn that off so you could see this. Now, I'm going to go ahead and let this hang like this, and there's a reason it's hanging. We've got a Bluetooth network adapter that has no idea what's going on with DHCP, so it's hanging there. And we also got a virtualized or a loopback adapter too. So I'm going to go ahead, and what I'll do is open another command prompt, and we're going to run ipconfig. All right, here's what I wanted to see. Like I said, it'll probably time out after a bit, and I'll just leave this in the background so you can see what I mean when it says it errors out. Notice this address here that I've got. All right, notice that it says auto configuration. This is a true automatic IP address, right? And the automatic IP address, a PIPA address, if you will, has a specific format that doesn't change. All right, and what I mean by that is that, first of all, it always has host bits of 255.255.0.0, which means the first 2 octets are always the network ID. So you will always see in a PIPA address start with 169.254. The last 2 octets, notice zeros. If you're not aware of that, go back and look at our IP addressing sites. Those are the host bits. That's right, Zach. So that means these last 2 octets, it gives me 65,534 possibilities, and my computer will generate this. It'll call out to the network and say, hey, I'm going to take and assign this a PIPA address. And then it says 179.130, and then it listens. And if no other computer has that address, it says, okay, I'll assign it to the adapter. Now, it's going to broadcast that communication out, and if another adapter, another computer says, well, wait a second, .179.130, that's my PIPA address right now, my computer will say, I'm sorry, let the rest of the network know, yeah, that's his address, not mine, and then it'll regenerate the last 2 octets, and it'll repeat the process until it finds a unique PIPA address.
Perfect.
But that is when there is no DHCP server out there on the network. Now, let's go ahead, and I'm going to reinitialize the DHCP server on this network. I am on VMnet 3 here. Let's make a couple of changes. So we'll click the lock here, and I'll type in my super secret password, and that'll just be between me, you, and Facebook.
Oh, yeah.
And I'm going to say provide DHCP. We'll go ahead and apply this. So essentially, we're turning the DHCP server or service back on. All right, and we're going to run our IP config. Notice I still have a PIPA address, right? So it didn't go away.
Nope.
But let's go ahead and let's start the DORA process by choosing an IP config /renew. All right, now, while we're waiting for that, which is going to probably, oh, it didn't time out. That happened really quick. Okay, I was going to say, here you can see an error occurred while renewing the interface, Ethernet 0. It said unable to contact your DHCP server. And it assigned an PIPA address, right? That's what we want to see. That's what should happen. All right. Now, notice here that we've got our IP address back. All right, so that's now renewing that IP address, says, hey, call back out to the DHCP server, and the DHCP server this time is listening and said, here's your IP address and here's your subnet mask. All right, so one of the last things I want to mention, we've been really just mentioning IPv4 addresses, right? I haven't mentioned how we obtain IPv6 addresses, and this is something that is important for the exam, all right? Now, one of the great things about IPv6 is it comes in two different flavors or modes, if you will. There's what's known as stateful mode and there's what's known as stateless mode, all right? Here's how you can think. Stateful mode, all right, means you are going to manually define that 128-bit address. You are going to statically assign it. That's stateful. Stateless is something that's a really cool feature that means the network adapter or the operating system can actually call out to the local network and say, I'm going to take this IP address. I'm going to assign my own IPv6 address. That's stateless. Think of stateful and stateless. Stateless, less work. They automatically do it. Stateful, full of work. You do the work, right? So that's one of the ways that you can remember this. So how do they automatically assign an IPv6 address without the use of a DHCP v6 server, right? Well, let me show you here. It's something known as EUI64. Now, let's talk about the format of our MAC address, right? Our MAC address is the layer 2 address that we were talking about before, right? Now, in that layer 2 address, you need to know the format, right? It is a 6-byte 48-bit address. Half of the address, the first 3 bytes, is what's known as the organizationally unique identifier. I put vendor ID just so you can know kind of what it's doing. It's identifying the company that made this network adapter. All right, and then the last 3 bytes, right? What would that be? The last 24 bits. That's reserved to uniquely identify that network adapter within the company, right? That's how we uniquely keep, that's what makes MAC addresses unique. First 3 bytes identifies the company who made the network adapter. The last 3 bytes is just unique within that company, differentiating all the different network adapters that they created. All right, so this is that layer 2 address. Well, in order to automatically assign the layer 3 address, what it does, we need a 64-bit identifier, 64-bit identifier, if you will, for this address. How does it do that, right? Well, to assign a EUI64 address to automatically get your IPv6 address, what it does is it takes your MAC address, all right, and it divides it in half, and then there are some reserved bits or bytes, 2 bytes here, that are reserved for EUI64. And it puts them smack dab in the middle of these 2 pieces, and it gives you a 64-bit network interface, right? You'll learn in our IPv6, we still got the same process, right? We got half of the 64 bits that are reserved for the network interface. The other half, the 64 bits, right, is going to be the network interface that uniquely identifies that network adapter, right, for our overall 128 bits. This is how your adapters can automatically assign an IPv6 address. They just take your MAC address, use those special set of bits, slip it right in between the 2 portions of your MAC address, and sign that to the network interface, and essentially you now have your IPv6 address, all right? So that's EUI64. Now, I will tell you with DHCP v6, a lot of times what we'll do is we'll do a stateless mode, not stateful. You can do stateful mode where you define what the IP addresses are. You can manually configure the DHCP v6 pool, the scope, like we've showed you in other episodes how to create a v4 scope. All right, but what we do a lot of times is we let EUI64, we let the network adapters assign, we leave them in stateless mode. All right, less work. And what we do is we go into our DHCP-v6 server and we just say, we're just going to let the computers, they're going to call out for DHCP. We're going to let them assign their addresses, but we'll just take the options and hand them out to the network adapter. So we'll control their network parameters, but we'll let them go ahead and assign their IP addresses. That is essentially one of the easier ways to use the DHCP-v6 service, if you will. Last but not least, and I know we're running a little bit short on time here, Zach. Zach's giving me that eye. I got one more thing that I do want to mention, and that's what they call virtual IPs. All right? What is a virtual IP? Well, a virtual IP is actually about redundancy, all right? And to kind of understand what's going on, I've got a little network here that we need to take a look at, all right? Now, I want you to notice that we have two routers here, all right? I have a router, and its IP address is 192.168.1.2. I have another router here, 192.168.1.3, all right? Now, if I didn't have redundancy in my network, all right, and this PC needed to send information out to the internet, what would it do? Well, it would use its default gateway, which would be this router. So it would send information from itself to the switch, then the switch would send it up to the router, and then from the router would route it out to the internet for us, right? Now, here's a question. What happens if this router was to go offline? What happens to the default gateway? Well, the default gateway goes with it, right? Router's offline, default gateway goes out the door with it. This computer can no longer communicate with the internet, right? So wouldn't it be nice if we had a way, all right, and we could still do a little bit of redundancy here by connecting the switch, if you will, to both routers. But wouldn't it be nice, because if I lose this router, right, this would work, right? This would give me a little bit of redundancy. If that router goes offline, right, well, I can still communicate. If this router goes offline, I can still send information to this router. But I want you to see something. The IP addresses are different. So this isn't going to be something that happens automatically. So it's technically not a failover, because I'd have to go back in and reconfigure these three computers with a new IP address for their default gateway. That's not really feasible. So what we can do is we can use what are known as virtual IP addresses. What I can do is we can set up the interfaces to where we have a virtual IP address. And what I can do is we can configure them to have a 192.168.1 virtual IP address. And what this kind of does for us is this kind of makes a virtual interface. All right? And what we're doing is we use things like the hot standby routing protocol, common address redundancy protocol, or the virtual router redundancy protocol. There's three different ways. Two of them are industry standards. The hot spare routing protocol, or I'm sorry, hot standby routing protocol, that's actually proprietary to Cisco. But what this allows is, in this case, what we're doing is we are configuring these two routers to respond to a virtual IP of 192.168.1.1. So now what happens when this router goes offline? Well, I'm not using their IP addresses for the default gateway anymore. What we're using is quite literally the virtual IP or virtual interface we set up for the default gateways for both of these computers. All right, all of these computers, right? So now what happens is I don't have to worry about the fact that this default gateway, including the router, right, went offline, because they're not sending any information to that IP address. They're sending it to the virtual IP address, and because this router's offline, what the switch will do, in this case, we've just configured it to go talk to this router. And this router isn't responding to this IP address. It is routing traffic based on the virtual IP address. All right, well, what happens if it's the other router, right? What if the other router goes offline? All right, well, these computers here, they're not using its IP address to send communications. They're using the virtual IP address. So they can continue to send 192.168.1.1, and with these protocols, it says, oh, I see that that router's gone, so we have to redirect that traffic through this router out to the internet. So this is about redundancy. Our virtual IP addresses are about redundancy so that we can have a virtual interface with a virtual IP, all done in software using these protocols. And if one of these routers goes offline, well, if the internet goes offline, then we're really in trouble. But if one of these routers goes offline, then through those protocols, it will route traffic to the other router. And again, it's based on that virtual default gateway.
It's like sending a police officer out when the lights are down.
Yep.
This is the way you go. No, you stop me, you come.
That's right. So you got a traffic control cop, right? All right. So those are a couple of the technologies that we need to be aware of. So keep that in mind on how we get our IP addresses. Remember, it's dynamic. They're static, very manual process. There is true automatic, which is zero configuration technologies. Be aware of how the EUI64, as well as things like, for instance, our virtual IPs, so that when you sit that Net Plus exam, you'll knock it out of the ballpark.
Wonderful job, Wes. Thank you very much. IP address assignments. Great episode. And all the episodes inside the CompTIA Net Plus series are fantastic. Wes has worked hard to put them together for you. Make sure you watch them all. And in fact, when you're in that course library, there's hundreds of other videos, and they're all designed to help you go further. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryant.
And we'll see you soon.
Thank you for watching IT Pro TV.